Really fun topic. Couple of disclaimers. If you build something from this talk, that's not on me, man. Like, you're totally in charge of your own destiny there. I don't support anarchists, but, well, it's a fun topic. Okay, so who in here has ever built a rocket or a missile before? Yes, they're the terrorists. I'm kidding. Yeah, aircraft. Okay, so y'all have had some experience with that. It's a very fun thing. I figured out a way to make one in your backyard for less than $50 US. Okay, so a couple of quick challenges. When you're trying to deal with hacking something like a rocket or a missile or a hypersonic object, what do you think the biggest challenge is with that?
Weight.
Surprisingly, it's not the weight or the weight to power ratio. Yeah, it's not the power to weight ratio. Actually, yeah, that's exactly it. That's surprising. I'm surprised anybody got that. But yeah, it's actually getting it where you want it to be. Now, assuming you have a radar system to see it coming, the biggest issue with hacking an object like a missile or a rocket isn't the fact that it's super secure, because unfortunately it's incredibly exposed. It's actually catching up to it to actually be able to manipulate it. And so you have to have a variety of systems previously in place or ready to be in place. So humorously enough, most missile defense systems are actually pointed in the wrong direction. They always point them out. They need to be pointed inward. And you just need to fire from the other side. But yeah, that's a different issue. That's a defense problem, not mine. So when you want to build your own missile or rocket, which you're eventually going to try, what you need: shopping list. You need stump remover, potassium nitride specifically, so you can crush it up, grind it down, pulverize it, and then put it into a bowl of water to make it crystallize, and then grind those crystals down because it's now purified. You're going to need some rust, preferably red rust. It makes better solid-state rocket fuel, surprisingly. And then you need sugar. That's it. Oh, the secret to making a rocket is things you can find in your house by accident. Then we need to add a few more interesting ingredients. Start with the Raspberry Pi. A Raspberry Pi comes capable of everything you need in a missile controller. Like, it's astounding. You need a servo controller and a servo arm to control the fins for direction base. If you really want to get crafty, you can even build an AI and attach a camera to the head. And then you can actually identify objects and track specific objects. That's what I would recommend. That's what I did with my designs, which I never, ever built in the US, because that would be illegal. Really illegal. Like DOJ Class 13 requirements, illegal. So, that being said, you can actually print the bodies. You can print the bodies. The only distinctive difference between a missile and a rocket is literally the shell design and intent. Missiles are generally designed to, blow things up, and rockets are designed to blow things up. But they can also be used for transport. So, yeah, for scientific purposes, you are building a observation rocket, if anyone comes asking, and it's for a science experiment. That seems to work. I don't know why. Unless they want to arrest a shitload of high school students. But yes, once you have it put together, the most interesting thing about it, most rockets and most missiles are controlled with SCADA infrastructure. So you've got the trigger arms, whichever the launching system is. They're normally locally controlled. Interestingly enough, a lot of them have wireless built into them, so that you can send the signal directly from the control console to the missile itself, which ignites the payload. Merry Christmas. Well, for somebody. So here's the issue with that. If you have wireless in a missile, when it's Merry Christmas, it's still there, and it's still on. So this is what I like to call the not Java drive-by. So when it's going, you can fire another one substantially closer by, and you can actually parallel park right next to another rocket or missile, because their proximity systems aren't designed to watch their sides. They don't watch their six. They watch the head-on. They don't look for anything behind them or beside them, which is crazy. I don't know why. I didn't build it. So, how these systems operate. There are two ways to control these things. If it is a smart system, it has built-in intelligence and can be controlled remotely, generally with a satellite communications feed. If it is a dumb system, it can be controlled by the guy who pushed the button that one time. That's it. So once it's going, it's either gone or it's gone. So if you parallel park next to this bad boy and you're doing Mach 2, you've got, generally depending on how much fuel you have in your system, anywhere between 6 and 11 seconds to hack the other missile. Here's the issue. You have to keep up with TCP acceleration issues. You have to keep up with the system. So you have a wide array of systems you have to penetrate. And you have to know what kind of communications channel it uses. So that's why it's custom. Because if I was like Patriot missile, I'd go to jail. So it's not the Patriot missile, but there are plenty of missiles that are operating on XP, Vista, Ubuntu 12.04. You know, super secure, highly hardened operating systems. So you could never just totally pack a shitload of shells into the Raspberry Pi, parallel park it, and just, you know, change the direction a little bit. Or, you know, Raspberry Pi, turn on a jammer. Oops. So, those are the interesting components about those two. Now, the other aspect. How much time do I have? Time? Am I good? 5? Okay. Hypersonic projectiles. Sounds really cool, right? Super smart. It's pretty much just an electrified rail firing a tungsten rod. And unfortunately, super dumb. Like slingshot with electricity. That's about it. So, how do you hack something that is literally a, pretty much at this point, molten rod of tungsten flying at something? Quite simple. You don't. What you can do, though, is you can distort it a lot. Surprisingly easily. So the issue with a dumb projectile, and the reason why we have smart bombs, is that if you put literally anything in its path that could distort the air, generate a large magnetic field, create a large anti-magnetic field, add a lot of water, you know, all these things that would never happen midair, ever. Heaven forbid, a cloud, you know, in the sky. But surprisingly, it's actually, I'm kidding, it's incredibly easy to generate those. So how do you generate a hypersonic projectile? Well, it's quite simple. You need a tin can. You need about 8 of those. You need 2 steel rods, preferably galvanized steel. You need a steel rod that can roll. And you need graphene, which you can make from graphite lead sheets that you can buy at, well, a dollar store. And then you need 2 9-volt batteries, and you need some wire, which you can then use to generate your own graphene. And then from that, you can create a supercapacitor, which is one of the most advanced ones on the planet in terms of voltage. You can put them in a series and a parallel, drop down your 2 steel rods, drop down your rolling rod, and then you drop down your tungsten projectile, or, you know, anything that can drop water, because, you know, hard objects shatter when they hit water. You could put a concussive object in that, where it creates a displacement in midair. All of a sudden, it's flying at 400,000 miles per second. It hits an empty airspace. Well, guess what? Its trajectory was just adjusted. Oops. There goes Bob's Barbecue. Instead of Billy Bob McJihad. Oops. Or, you know, cargo plane. Oops. But yeah, it's actually quite easy to build. Supercapacitors are pretty awesome. Obviously extremely dangerous. I would say don't try this at home, but well, I know the group. There's going to be at least 2 people with missing fingers come next month. So I'm looking forward to that follow-up on the Twitter stream there. I'm super excited. So are there any questions?